Next, we'll look at the curve formed by an equation of y equals to cos theta. And in this example, we have plotted the curve from 0 degrees up until 360 degrees. We can notice that cos of 0 is equals to 1, cos of 180 degrees is equals to -1, and cos of 360 degrees is equal to 1. And then cos of 90 and 270 degrees are both equal to 0. So this is the curve of the base graph of cos theta. Now I'm going to use this curve to discuss the properties of cosine of theta in the first quadrant all the way to the fourth quadrant. First, quadrant 1 is represented between 0 and 90 degrees. And on our graph, between 0 and 90 degrees, we can see that the cosine graph is above the x-axis, meaning it is a positive value. So cos would be positive in the first quadrant. Next, the second quadrant is between 90 and 180 degrees. And on our graph, between 90 and 180 degrees, which is the second quadrant, we can see that the cosine graph is below the x-axis, meaning it's on negative values of y. So the cosine of theta is negative in the second quadrant. In the third quadrant, which is between 180 and 270 degrees, and on the graph between 180 and 270 degrees, we can see that the cosine graph is below the x-axis, so it has negative values for any value of theta between 180 and 270 degrees. Therefore, cos theta is negative in the third quadrant. And finally, the fourth quadrant is between 270 degrees and 360 degrees. On the function, we can see that cosine of theta in the fourth quadrant is above the x-axis, meaning that it has positive values. So cosine is positive in the fourth quadrant.